So this is the MATE ROV competition. What is the competition? So MATE is the underwater competition. They use remotely operated vehicles or ROVs to challenge their K through 12 and college students to solve real world problems based on real world scenarios using their scientific, engineering, and technical skills. So this forces the students to think of themselves as entrepreneurs as they have to manufacture, market, and sell their product. The competition began in 2001 and now has up to 40 regional competitions that take place worldwide. So the map on the left shows where all of the competitions take place. So as you can see, it's a global competition. There are different categories to the competition scoring. The first is the product demonstration. This is where the ROV actually goes underwater and completes missions. They are scored on what they're able to complete, and if the teams can complete everything, they also get a time bonus. Next is the product presentation. So for this portion, the teams give an oral presentation to a panel of working professionals, which is then followed by a Q&A period. There's also a technical documentation portion, and this is just a written report detailing the design of their vehicle and how it works. There is a marketing display portion, which is just a poster showcasing the vehicle and all of its features. There's also a company spec sheet. This is not required at all regional events. It's only required at the World Championship. So this is just a one-page brief description of their team and their ROV. And the corporate responsibility is also not, it's not necessary. It's only offered at some regional events and at the World Championship. And this is just a way for teams to kind of demonstrate how they've given back to their community, whether that be through volunteer work or through outreach using social media platforms. There are different competition classes for the competition, which is based on level of difficulty and experience. The Explorer class is the most advanced class. This is for universities, colleges, and high schools that have competed with MATE before. These teams have a deep understanding of electronics, electricity, sensors, waterproofing, and other technologies. The Ranger is the intermediate class. This is for high school and middle schools with some robotics experience and colleges and universities that are brand new to it. So these teams have a good understanding of robotic systems, electricity, and some knowledge of waterproofing. The Navigator class is the beginner intermediate class. This is for middle schools with robotics experience, high schools, new to robotics, and advanced elementary schools. These teams have some understanding of robotic systems and electricity. This is a good competition class if your teams have experience with robotics but have never actually competed in a competition before. And the beginner class is the Scout class. So this is for elementary schools, middle schools, and beginning high schools. These are for teams that are completely new to robotics or have very limited experience. And because it is a beginner class, there are instructions, tutorials, and lesson plans to walk teams through each step of the way, as well as ROV kits that provide all of the materials needed to build the ROV. So what exactly is the ROV? It's made of many systems that have been constructed independently and then put together to make one big ROV. So the first part is the frame. This is a sturdy 3D structure that holds everything together. Next, we have our power, which just provides the electrical pathway to get from the surface where the controller is to the ROV underwater. You have your controls, which allows the driver to control thrusters, tools, cameras, lights, and other subsystems of the ROV. You have the tether, which is just a wire that goes from the controller at the surface to the ROV underwater, and it transmits the data between the two. There's the propulsion, which allows the ROV to move through the water. You have your buoyancy, which allows the ROV to sink and float, and mission tools, such as grippers, sensors, and other tools needed to complete the mission tasks. There are ROV kits available for you to use, and they typically go along with the competition class. So the angelfish and the pufferfish are going to go with your intermediate and advanced classes, which are the Explorer and the Ranger. And then the triggerfish and the barracuda are going to go with your beginner and beginner intermediate classes, which are the Scout and the Navigator. We recommend the pufferfish because it provides all of the materials that you need to build the ROV. And again, it goes with the Scout level, which is what we recommend if you're brand new to this. So each year, MATE releases a theme, which is what all of their missions are based on. This year's theme is Excite, Educate, Empower, Students Engineering Solutions to Global Problems. There are 3 tasks which the missions are based on. The first task is the ubiquitous problem of plastic pollution. So these missions will have to deal with remediation of plastics clogging our rivers, lakes, waterways, and oceans. An example of one of these missions would be the robot having to gather plastic debris from the surface of the water and bringing it back to the surface. The second task is the catastrophic impact of climate change on coral reefs. This would have to deal with remediation of health on coral reefs affected by climate change and ocean temperatures changing. And the third task is maintaining healthy waterways part 2, Delaware River and Bay. And this deals with remediation of contaminants on our waterways. So an example of one of these missions would be the robot having to gather sediment from the bottom of the water and bring it back up to the surface for testing. Next, I'm just going to share with you all some impact study data that MATE gathered in 2019. So students said that they are more interested in math and science after competing in MATE than they were before. 83% said they wanted to learn more about STEM, and 76% said they were more interested in having a STEM career. The second figure shows that students have an increased skills and knowledge after competing in MATE. 90% of the students said they had an increase in engineering skills and knowledge. 88% of the students said they had an increase in technology skills and knowledge. 76% said they had an increase in science. 64% said they had an increase in math. Teachers also have said that they've seen their students make major improvements after the competition. 98% said they observed improvements in their students' STEM knowledge and skills, and 97% said they saw improvements in their team building, critical thinking, and problem solving. Next, I'm going to show you all some resource links that are just helpful. So the MATE ROV website is going to be your best friend. It's where you can find competition manuals, competition rules, and I'll take you through the link in a little bit. The CMATE store is where you can get all your ROV kits. And again, you can access the CMATE store from the ROV website. MATE also has a Facebook page where they put a lot of updates based on their regional events, any changes. I've also added our emails. So now I will take you all through the ROV website. So this is the ROV, the MATE ROV website. Their homepage just has announcements. This announcement was about the coronavirus. If you go to challenge, it'll tell you, and you go to start competing, it'll tell you about the different competition classes. So we can go here, it'll tell you more about the classes, more about the aspects of the competition. And if you actually click on the challenge, it'll take you to this page. So let's say we are going to compete in the scout level. We can go to here, the scout challenge. And then here you can find the competition manual, prop building instructions. There's even a video, which we will show you all later. It just kind of shows what the missions look like. So the most important thing here is the competition manual, but it just tells you about all of the tasks and the missions. It goes into depth about the entire competition. And then over here, if you go to teams, you can find the CMATE store, which is where you would find your ROV kits. So you could go over here. You can search for your kit. There is also a forum where you can ask questions about the competition. And yeah, there's more to the website, but the most important part is definitely finding your competition manuals, which are going to be here under the challenge page. So that is all I have for you all. I will now hand the floor over to Sharon, where she can go into depth about the competitions.
Okay, so I'm going to go a little bit in depth about the Scout class. Now, Thais, you mentioned about where to buy the kits, and I think from what Dr. Ivy said, we are actually going to provide those kits for you. so you won't have to really pay out of pocket for a lot of this stuff. So let's talk about how you're going to get started with your schools. We'll dive into the actual pufferfish kit, how to build the ROV, the engineering and communication side, which is a big part of the competition, kind of the competition timing of what we're looking at and why mate is a good choice. So getting started. As Thais said, scout level is the most basic level. It's meant for really any age, as long as they're really new to robotics and underwater robotics. So it really depends how many schools we are going to have participate. We may have to split up the levels. We don't want, middle schoolers or like K through 4 competing against high schoolers. It just wouldn't be fair. As team-wise, Katie and I were talking, and we're thinking about if you want to have more than one team, I think that would be okay, but definitely a minimum of 2 students per team. So when you're introducing this to your students or just to your school and trying to get it started, there are a lot of STEM lessons built into MATE. You need to pull out those key concepts like buoyancy, circuits, and conservation. And we were talking, and we are thinking that maybe we could host workshops for y'all if that would be easy for you. So we know a lot of you aren't or may not have a lot of background knowledge in this stuff. And so to help you out, we're thinking of having a series of workshops throughout the year to help prepare for the competition. But on your end, you can definitely learn the competition objectives. Everything's on that website. You can reach out to us. We have plenty of information. Terminology will be a big thing. You may see some words you've never seen before. So constructing, you need to create a game plan and gather the materials. So the pufferfish kit, which I'm about to dive into, it comes with a lot of things you need, but there are still items that you will want to invest in if we're still deciding if we are going to buy it for you. So there's a soldering iron, which I'll talk about later. And then the PVC pipe. So if you look at this picture, the yellow is actually the PVC. That is going to be for the structure of your ROV. So that will be something that you'll have to decide how much you want. And then for buoyancy, you need to figure out if it's going to float or not. And for that, they use the pool noodle, and they just kind of cut it up and tape it around. I would set about 2 to 3 hours aside to actually build your ROV. It can be time consuming, especially if you don't prepare a game plan and design beforehand and you're just kind of messing around, let the kids play around. It could be very time consuming. So the engineering and communication components, this is going to be the other side of the competition. So after you have this ROV, you do the product demonstration, which is actually putting it in the water and going through the challenge. There's more to MATE. You have the students are basically entrepreneurs, so they create this company or business. So they have a technical documentation, engineering presentation, and marketing display as well. And I'll dive into those. So just to give you an idea of kind of what the robot is. So on the left is a real life robot that functions in the ocean. That's what people are using. The students are making the ROV on the right. So, it's made out of the PVC. It's very basic, but it still functions like a real ROV. So you've got the foam for buoyancy. You'll have thrusters for propulsion. So that's how it's going to move around. Tools. Now for the Scout class specifically, we won't be using certain tools like grippers or higher levels. They have an actual video camera that you have to look through. So as a Scout level, it's very basic. They can look into the pool while they're navigating. So it'll be a lot easier. The tether is going to be for those electrical cables. So you'll have to learn how to waterproof it, which we can help you as well. And then the frame, and that will be the PVC. Okay. So the pufferfish ROV kits. So the pufferfish in general, it's many systems, they're independently made, and then you put them all together. So as I said earlier, we're not going to use grippers or camera add-ons. This is very starter level, very simple, so it won't be too hard for you. So the major systems, you're going to have your frame, your power, control, propulsion, and buoyancy. And the buoyancy is what the pool noodle was used for. So the frame is just the 3D structure that is up to the students to decide what's best for the competition. I'll show you kind of what the the props look like later. The power is going to be that electrical tether. You'll have to waterproof it, so that'll be another objective for them to kind of figure out how to do. And then the control system, that's going to be the control box. So that's where the circuits come in, and they have to actually solder the circuit board together. So definitely need some help the students, but just like shadow them, I guess. Propulsion, that is going to be the motors. So you'll put the motors together, you'll build them, and then once you build each piece, you put it all together, and then you've got your ROV. So it's kind of step by step, and we have all the information and links to give to you if you want them. So we'll dive into the components of a pufferfish kit. So we hosted a workshop not too long ago, and some teachers received the kit at the end. So we will be giving the teachers, if you decide to do this, a kit as well. So on the right side is the control system. So that control box is going to be how they move their ROV underwater. So the little green printed circuit board right there, that is completely blank. You get all the pieces to put in it. We have instruction manuals for that as well. And you will need a soldering iron. That may be a purchase that we invest in. We are still deciding that, but we're also thinking about hosting a workshop because I personally have never soldered before until I went to a Meet ROV workshop. So it's definitely different and very dangerous. So we'll have to watch the students as they're doing it, because students are supposed to have full control of, you know, this competition. They're building the bot, they're learning all the concepts, they're building their business, selling it. So we are there to just encourage them and support them and also learn. So the left side is going to be part of the tethering system and some of the mounts for the motors. That's what those 3 PVC motor mounts look like. The motors will sit in it. And so you build each little section off on its own, and then you put it all together at the end. So this is just a little bit more about the control system, because circuits, it's a little bit different for some people like me. So over on the left, I put 2 links, tools and supplies. So the tools cost sheet, it talks about each tool that you may need to put the ROV together, and it tells you if you absolutely need to purchase it or not. And it also has some good prices for them. So that I think would be very resourceful to have. And then if there's stuff that we can help you with, definitely reach out to us. So building the ROV, I listed some time frames so you can better manage your time, because some of this stuff, some of it's really easy and then some of it is really time consuming. So when you're thinking about your team and putting it together and having them work to build the ROV, you need to kind of plan ahead and make sure you have time set aside, because like the control system is very time consuming. You have to solder each little piece on, and that you'll want to set time aside. So the frame, depending on how much planning you do, it could be as easy as 30 minutes, or it could take up to 2 hours. It depends if you're doing the planning and design along with building the frame and knocking it all out at once, or kind of separating it out. The power system and tethering, 30 minutes to an hour, I'd say. The control system, so that's that control box with the circuits, most time consuming. And then the propulsion and buoyancy. Buoyancy, it really doesn't take long. At that point, your ROV is built, you're putting it in the water, and you're just testing if it's rising to the top or sinking to the bottom, because you want that sweet spot in between. And then I put a link here for ROV instructions. This link will tell you kind of how to do everything, like what you need, ways to consider a good frame design. It really just walks you through each system and how to kind of put it together. And it's got individual links in it as well. So you can learn how to tether the control box. You can learn how to waterproof it if you want to reuse it. So that link is really good, which is why I put it in there. And then, so now I want to talk about the engineering and communication side of the Scout class. So you build your ROV and then you get to demonstrate how it works, and you have those objectives in the pool. But you also get to sell your business and kind of sell your vehicle as well. So your students are entrepreneurs. They need to be able to communicate information about their ROV, not just did they build it, did they put some hands on it? Like, are they learning? Can they learn all these real life applications? So you want to know, like, what's the design and build process? Are they doing more than just operating in the water? So the competition requires the following. Now the spec sheet, I think we said was just for the worlds, but I did put it in there. The technical written document, engineering oral presentation, and then the marketing display. So there's a whole bunch of stuff. This link is actually for the manual. If you go to page 43, it takes you directly to these specific parts. So the engineering communication, we'll talk about the spec sheet. So it really just provides the judges with a snapshot of the company. It's basic information about the company and vehicle, and it's a page in length. So just more about the team itself, and then the ROV, size, weight, total cost, very cut and dry. And now I put in the initial safety review link. It will just show you kind of like a checklist. So the technical written document, this is gonna be a bigger portion. It challenges the students to effectively and efficiently communicate information. So they need to learn to be clear and concise in their text. They need to incorporate graphics, illustrations, and data, and referencing those as well. So the focus will be the technical and safety of ROV and ROV systems. So the ROV as a whole, and then each kind of system, like we have the control box and we have the propulsions. So it's very, it's broken down. The technical rubric will also show you, I'll open it. So the technical rubric, I put a rubric in for each section, so you won't have to search too hard for all of those, but they're all under the MATE website as well, under the challenges that Thais showed you. So it kind of just goes through what they're looking for. It's very cut and dry as well. So that's kind of what that looks like. The oral presentation. So this is where their business kind of comes in. So they are coming all this way to a competition, which for them will be local. But you want to think of it as a sales pitch. So you want them to organize and present information, covers the development and testing process of the ROV. So about 5 to 10 minutes to deliver the presentation, and then 5 to 10 minutes Q&A with a panel. So the panel is typically, like the judges are typically professional engineers, or even in different work areas. So what's important about this oral presentation is there aren't any visuals or visual aids for the students. So they don't have their actual marketing display with them, no PowerPoint, but they can create like a handout to give to the judges. So it's strictly about having that conversation, the technical conversation with the professionals. It's really cool. So they represent their company to a group of judges, face-to-face interaction. They evaluate, judges evaluate the presentation, no visual aids. Company allows the handouts, and then all members of the team should participate. It's kind of like a must, you know, you want everyone just contributed. And then I attached the rubric there. Okay, the last one is marketing display. So this is where all the visual stuff comes in. You want this to cater to people who aren't very technical. So all these judges, typically there's you know, they're not all engineers or they're not all scientists or in the STEM education or field. So you'll have marketers look at these, or you'll have I don't know, like an artist or something like that, you know. So you want them to be able to convey information to those who don't or haven't, I guess, dive deep into main underwater robotics. So just some helpful tips I provided for this part. I also have the rubric. You want to start with the rubric, do your research. There are some required headings. You want to add personality and then edit and proofread. I just put some little cheats in there. But for the required headings, there is also a link for that under the Mate store, or not the Mate store, but the Mate website. Okay, so competition. This was a slide in Thais's PowerPoint, just to kind of remind you what the objectives are. So competition timing wise, now with COVID-19, we're pushing everything back, but Mate has decided that the competition is going to stay the same. So they're not going to change the objectives or anything. It's just going to roll over into 2021, which is nice. So we are definitely going to host it at the University of Memphis. We do have a pool that would be perfect for the competition. Now, when it comes to competition, the students are going to want to practice driving their ROV. You're not going to be able to drive it if it's not in water. So that we will leave up to you. If you have a pool or can get access to a pool to practice, that's great. But if not, reach out to us. And if we have enough people, we can schedule a practice event for you. And maybe we can have a limited amount, do multiple days, have y'all come out, practice driving your ROV with the props. So this is the competition prop layout. And what we are going to do is we are going to invest in this, create it. It's all made out of PVC pipe and a couple other materials. So we'll make the competition props and we'll set it up and then host those practice events so you can come out and practice the actual competition. So the predicted agenda, you'll want to do a safety inspection. That is also one of those links. The product demonstration is when they're actually driving it in the water. And then you'll go through the technical documentation, the marketing display, and then the engineering presentation. And then afterwards, we'll do awards. So that's a rough agenda. Time-wise, everything's kind of up in the air and we're still finalizing things. But if you have ideas or recommendations for what you want to see through the school year, definitely reach out to us. I think we're going to host an open discussion afterwards. Oh, I do want to go through the videos. So this is going to be the Scout competition video. It's just going to fly through it. I think it's like 3 minutes long. We just want you to know that we are here for you. And if it seems overwhelming, it is a lot of information, but once you go through it, it's hard. So we'll go through this. Yeah, so that's kind of an overview. I did notice I had grippers, so I didn't see how they were working. So we may have to go back through that and check on the gripper part. But when I went through the main ROV workshop and we built the ROV, we didn't add any extra stuff like that because the scout level is very basic. So we will definitely check up on that for sure. So I want to talk about why mate ROV in case you still have doubts. So it's great for career exploration. All these kids, you know, we live in Tennessee, we're not very close to the ocean. And so maybe they really want to dive into marine biology or that kind of career. So this is a way to really get them interested and to give them a background for when they do get to make the choice on colleges and careers. Also, they use ROVs for conservation. That's a big part of MATE, learning about conservation, and robots are cool. MATE's well established around the world, so it's just backing up the world resume kind of thing. Real world application, and they get to practice soft skills, which is really important, and team collaboration. So there's a lot going on with MATE, and we hope that you're just kind of interested, and we will help you get there as well. So this is just about the Flower Garden Banks National Marine Sanctuary. It's in the Gulf of Mexico, but this is an actual ROV named Yogi, and he is currently studying like black coral, biodiversity in the reef, collecting samples, observing coral spawning, and then retrieving data to expand the sanctuary. So this is an ROV of mates that they have actually created. So they do use ROVs in real life, and it's a big part of the world. This is just some contact information if you want more information from us. I think we're about to do an open discussion so we can talk about questions you have or concerns.